wave, but due to some reason, how there will be one longitudinal wavelength, there will be some sidewise wavelengths, generation of some sidewise wavelengths. You get something tensor of wavelength and frequency. Tonight, I'm going to discuss about how the wave forms mass, how electron gets mass due to the wave analysis. The complex matter wave analysis due to my design. These are my works completely, not the complete proven theory. I study about the proven theories, and these are my works. I think about it, and then I explain it in my words with my own equations. It may be right, it may be wrong. Is there anyone in live? Zero?
Put the topic.
Yes.
It's the usual timing.
Matter. Is there anyone? No. Later build food zoning. Now see. Not even fluctuating even. Over idea. Wait, don't worry. You can't do anything in live. Live doesn't mean you have to always on a screen. 11 people have that's still 11 0. Now see how electron gets mass from the wave, matter wave. Matter wave is a complex matter. These are my works. It might be wrong, it may be right in future. Let's see. I'm trying to explain quantum physics as simply as possible, as easy as possible. I'm working on the reduction of uncertainty in quantum mechanics. Quantum mechanics is highly uncertain. There are many theories which are very much mathematical, but we carry it in physics without understanding its physical significance. And there are many theories which are physically easy to understand, but no mathematical concepts. That's why it's not going through quantum mechanics. Let's see. How the mass comes for electron from matter wave. If you're familiar with my channel, then you understood or you have seen any videos on my channel that is explaining about electron spin. And according to me, according to my works, I assume electron as a longitudinal matter wave, longitudinal-like wave has some transverse-like component around it. And you can see here, let's see, tilt it to show the detail. Is this still 11?
Yeah.
Okay, fine, that's right. See, is it visible?
Yeah, it's visible.
Now see, my electron design, the complex matter wave for an electron,
Yeah, now it's visible.
according to me, the matter wave, complex matter wave for electron is this. It has one longitudinal wave-like component woven with a transverse-like component around it, and this is given the spin, 1/2 spin. I had already made a video over this on my channel. You can watch that to understand how 1 by 2 is a spin number for an electron. Here I am discussing how it gets the mass. See here. See here. As I told you, I'm taking two segments for ease. This doesn't work only on segment, but this will walk through all the points, all the space through a matter wave. Let's see. This is one segment, this is another segment. As I'm pulling this, means this segment is getting some velocity. And there, let's take two segments through this. Come to the board now. See, this is the longer longitudinal component. I have taken, these are my works. You can see it here.
Wait, I need to adjust it.
C and D. These are two sections. I have highlighted two sections. How many people? Those. Okay.
6.
Okay, see.
Just fluctuate it. 12, 8, 9, 6.
The matter complex wave for an electron, I have taken two segments. These are two highlighted segments in the wave. One is BC and one is CV. And whatever I'm analyzing over these segments, that will work to each and every point of that wave. This is for ease. See. Let this segment is gaining some velocity, very high velocity, relativistic velocity. Because what? Dirac spin.
There's a channel, Rohit Kumar Pandey,
Yes.
UH8QL, they are saying hi.
Yeah, hi everybody. Thanks for my live. You're watching it, taking interest in my life. And I'm explaining my own works. I'm explaining my own works. I started from the electron spin, trying to analyze electron spin in a very simple way. Why half integral value for electron spin?
Draw the line a little.
And then today, for today's live, if you have any other question, you can ask me. You can watch my videos on channel related with electron spin. And in today's live, I'm going to explain how from the matter complex wave, electron gets mass. From where it gets mass. These are my works. There may be some wrong in it or right in it. These are my works, my research works. See this. And
put up your pen here twice.
Here, okay. You can ask me question. If I'll be capable, I will answer it. Or if I will not be capable, then I tell you that I will work on it, then I will answer you. See. Suppose this segment gains some velocity, very high velocity, relativistic velocity. What would happen? This is a junction point, think. Means the velocity achieved by this segment will be transferring to this segment. But here is a twist.
They are asking you,
Yeah.
the same person, Rohit Kumar Pandey.
Yes.
As of now, please explain any topic which I can understand. Okay, this is.
What topic do you want to get in live today? Tell me, I will explain that topic.
Yeah. Wait for the comment.
Okay, I'm waiting.
Which topic would you like to?
Yes, tell me a topic, whatever you like to know right now, I'll explain that.
He joined just now and he, I think, didn't have the idea that what are you actually explaining it here. See.
Yes.
And he.
Is it visible?
Yeah, everything is visible.
Read this. How electron gets mass from the matter complex wave.
This is a quantum analysis of electron spin and electron mass.
Yes.
So in the video,
Yeah.
you can see the previous video.
You can watch my videos at my channel. My YouTube channel is Physics and Universe. There you can get videos based on electron spin. Why electron has spin? Why the value is 1 by 2? Have we understand physically the what is the significance of 1 by 2? What type of physical interpretation for 1 by 2? These are my works. There may be some wrong or right. These are my works. I try to explain it very easily. My main motive, main goal is to reduce the uncertainty of quantum mechanics, because quantum mechanics is highly uncertain. We are carrying some theories, some concepts that are physically impossible to achieve, to grasp. These are mathematically only existing. So I'm trying to make physical intuition about quantum mechanics, reducing its uncertainty by my own works. It may be wrong, may be right. You can comment me or in future. See.
It's okay that you don't have the idea of this topic. You can watch it and to learn or think that what I'm trying to explain is it.
Are you familiar with E equals to mc square?
Wait for the. I think you must be familiar with it.
Okay.
This is a very common equation.
If you understand E equals to mc square, then you will understand it. I've tried to explain it in a very easy way.
Yeah, the answer is yes. I think they understand the E equals to MC. That's a very famous
Yes.
question.
So
We expect him.
be patient and watch my explanation, then ask me question.
Explain them first that you are explaining electron as the wave, not the particle point-like thing. See, before explain that thing.
The quantum model of electron.
Yeah.
See, according to Dirac, the spin, electron spin comes from relativistic speed of when an electron is approaching at relativistic speed, at very high speed, then it gains a spin. Not gains a spin, but then a spin is visible.
Okay, they are saying okay, continue, sir.
Okay, see this. These are my works. You can see, you can ask your ChatGPT, Google Lens, anywhere to know about this concept. And I have also studied from these things, from books, and these are my works out of it. See, this segment has gained some velocity, very high velocity.
This is an electron.
This is
Quantum model.
the quantum model of electron.
There is not a particle or ball-like thing.
In quantum model, electron is a wave. And what type of wave, no one knows. In quantum mechanics, the shape of wave hasn't given. No one knows what type of wave is it. They just say the matter wave. And matter wave is a complex wave, means it has some real part and some imaginary part. These are my works. I thought that if there is wave, there must be some shape and size. And according to me, my research work, for this you have to watch my previous videos on my channel. And I'm suggesting you that you should watch it. According to my works, electron is composed by a bigger longitudinal type wave through which a transverse wave has woven through it, and that is the result of half integral spin. Okay,
The dancing string.
You can see the dancing string. Okay, I'm showing you. See, a string theory is most promising theory explaining the fundamental particles. I'm showing you what is the possible. Thanks for being in my life. I'm highly appreciating your intuition and curiosity for this topic. See here, I'm showing you what is, according to my theory, how an electron looks like. It's like a dancing string. See, according to, is it visible?
Yes.
According to my theory, this is the existence of electron in complex world. One longitudinal component, and it has some transverse-like activity. Okay, keep in mind this and see my explanation tonight. I have skipped the transverse part here because transverse parts are very small due to longitudinal. So I'm explaining on longitudinal terms, then I will explain over this. This segment has gained some velocity, very high velocity, relativistic velocity. And this segment of the same matter wave is attached to this, means the velocity gained by this must travel to this segment. Here is a twist. it takes some time to deliver that speed. This segment is gaining this speed, and that speed will reach to this segment has taken some time. And here is a twist. In relativistic speed, CD notices that this speed has approached to this segment in del t dash. No, del t dash, no, del t time. And BC is noticing that the speed gained by CD is touching me in del t dash time. This is time dilation. Relativity time dilation. For the same event, two observers observing two different time intervals. Clear?
Quantum and relativity. There are
So, CD observes that I'm delivering my speed to this segment in del t time. And BC is observing that the speed delivered by CD to me in this time. This is a twist. So due to time dilation, you are familiar with the time dilation, and then you can say that now for BC, if BC is the observer, del t is equals to del t dash 1 minus v square by c square, means del t is observes a smaller time period than del t dash. Means this segment thinks that I'm delivering this speed in 1 second, and this segment thinks that I'm getting that speed in more than 1 second. That is time dilation. And the time dilation is the key here, according to me. What happened?
nothing.
See. And as these two segments from the same matter wave are behaving as two different observers. So, the change in time measured by both the frames. Change in time measured by measured in both the frames. In both the frames. See. Is del t dash minus del t, and the value is del t taking common this. The value of this difference is this.
Analyze a little bit which one is the proper time and which one is the measured time. Or you can watch.
I'm working in BC, in the frame reference of BC. See, according to a standard theory, that is a proven theory related to the quantum mechanics, quantum model of electron, that electron, a free electron, is composed of a matter wave that is infinitely big. Means if you talk about the shape of a wave which is representing an electron, is infinitely long throughout the space. One single electron, that is the smallest particle, has a wave nature infinitely long. Understood? So, and within that infinitely long wave, each and every point are not distinct observer. Whole wave is one single observer according to a standard theory. But according to me, no. Whole wave will not be a single observer. There must be different points in the wave or different observer. Because why? I'm here explaining why I have taken all the different points as different observer in the same wave. How they transmit their message. Where is the electron? Within that infinite wave, where the electron is forming, where the physical existence of electron is forming. For this, how they transmit that message from one observer to another, means one point to another point in this wave. That's why they are behaving as different observers. I think they have some design through which they can send the message faster than the speed of light. And that would be the revolutionary revolutionized theory in the quantum mechanics. Let's see. That's why I tell two different points or two different observers, and they're communicating to each other that where we should pops out electron as mass. The wave, infinite wave, the matter wave for an electron is infinitely big. But where the electron is there are several quantum states. At least there are not infinite quantum states, but several. So the different points from the same wave are talking that where we should pop out the electron. That's why I tell all the points behave as different observers. And instead of points, I have taken segment to understand it easily. Once you understand the concept, my explanation of a segments apply to each and every points in the matter wave. Let's see. So this is the difference in time noted by these two segments achieving the velocity. Clear? And I'm taking this difference del t dash minus del t as del t 1 minus this. And this will be, give it some name. See. Understood? Okay, that is.
This topic is quite high for a lot of people.
That's why I thought to make some video for it not going in live. Okay, see here. One thing is clear, due to different observers, they are noticing different time during which they are getting the speed, relativistic speed. So, within these two segments, the time difference is this. And as we know, due to uncertainty principle, see, if you have any doubts, then you can ask me through messages. I'm erasing it due to shortness of my bowl. As we know, to the uncertainty principle from uncertainty principle, is there anybody? Uncertainty principle.
Someone came and went.
From uncertainty principle, you can see energy and time has also some uncertain relation among them. And that relation is this. Like momentum and position, we have uncertain relation among energy change and the time change for a quantum particle. See, this is the time difference in both the segments as they are two different observers. And this difference in time during which they are achieving same speed, there is some difference in the energy. There is some change in energy. And from here, I'm taking that h cross by 2 delta and put the value of this difference in time here. What are you getting? I'm taking just equal parts now. See, this is our result. And from this equation, from this equation, we have seen that both the segments have noticed there must be some loss of energy during that wave. And as it's expanding, this segment is expanding. This segment is going away from this segment. So due to the Doppler shift, there must be some, this segment notices reduced frequency and then increased wavelength. And if wavelength is increasing, then energy is decreasing. Means in the reference frame of this segment, due to gaining a speed of this segment, there is some loss of energy. And that loss of energy comes through this. That is del E. And as we know, del E is equals to del MC squared this. Clear? Del MC squared. Now bring this del T here. And we get H cross by 2c squared 1 minus under root 1 minus v squared by c squared. Here we got a relation, uncertainty relation among the mass and the time. And that tells you that the wave, the relativistic approach in the matter wave gives some mass here. Reduction of energy, lose of some energy, pops out some mass there. And that mass could be the possible position of physical electron that we notice as a point particle from the infinitely long complex matter wave. That's my work tonight. And I will explain like this uncertainty relation here. How electron gets mass from that infinitely long matter wave to a point particle. This is this. Now see, let me erase this. Yes, here, see, no need to erase it. Here, this uncertainty relation converts into an uncertainty relation of mass and time. Means the time this segment takes to deliver its speed to this segment is del T. Means as del T is smaller in magnitude, means if this segment is delivering its speed to this segment very fast, in that case what would happen? The change in mass is very large. So during that wave, infinitely long matter wave, which is complex in nature, how electron pops at some one place, another place, or several quantum places. It happens at once. As rapidly this segment delivers the speed to this segment, as large change in the mass, means as bigger mass you have for an electron. And as gradually it delivers its speed, a small change in mass. That's why you notice that the mass is constant there. Means in classical world, we think the electron is a point particle located at definite places. Why? In classical world, the change in time, the speed delivered by this segment to this segment has no any existence. It's almost negligible. No need to ask such question. That's why we do not have any uncertainty in the mass. But in the relativistic speed, when this delivers its speed to this segment, if it delivers quickly, we have very large mass, pops out everywhere. Means you have several quantum states with electron. That's the quantum mechanics. And if it delivers slowly, we have very certain, means one fixed position for the mass. And thus, electron, the mass of electron comes from the matter wave, which is means in wave mechanics, in quantum mechanics, the matter wave representing an electron is infinitely long. Where do you find electron? Physically, this mass is the electron in that infinitely long wave. This is for a free particle.
The explanation is finished?
I think it's almost finished. Now see, I have taken the CD and BC as two different segments of the same matter wave. But I told you It works on each and every point of the matter waves. Means the matter wave is spread out throughout the infinite region. And during that infinite region, each and every probable space points behave as different observers. And here the relativistic twist is changing you the mass from the energy, and that mass is our electron in classical world. In quantum world, the whole matter wave is our electron. Clear? Now see one thing. From this result, there are two possibilities. One is that it's delivering its speed to this segment. That speed is not delivered at once. It takes some time. Means the speed goes through this segment in a time. Means there must be some acceleration. And existence of acceleration gives you existence of force. And existence of force means that is, there must be some role of general relativity there to disturb it. Notice this for a free particle. And the second concept is del E equals to mc square, means conversion of mass into energy. We know easily that del E equals to mc square. Any mass which is moving at the speed of light can convert itself into energy completely. All its components will convert easily into energy at relativistic speed of light. But when energy converts into mass, in other way, when energy converts, not at each and every speed, energy converts into mass. There must be some critical time within which energy converts into mass. If the time is longer, energy will not convert into mass. That's why you can't find mass everywhere in the inverse. In that infinitely long matter wave, the mass of electron is not everywhere. Understood? And for next thing, for more details, and within this means for more works within this concept, I will be in next live. And I'll make a video over this and upload it on my channel, Physics and Inverse. You can watch it. How many are watching? No one. Okay, thanks for watching, being in my life.
ये टॉपिक बढ़िया है, पढ़ के